Welcome back, everyone, to the Sunday Night Astronomy Show. What did you do on your summer vacation? This fun fact number 25 of the year 2025 is more geared to what did you see on your summer vacation. The summer vacation season started off on July 2nd. Right after amazing fireworks on July 1st, there was a stellar bang, actually a double bang, as astronomers saw the first ever star to explode twice. This image of SNR 0509-75.5 was taken with ESO's Very Large Telescope's Multi-Unit Spectroscopic Explorer. In a stunning first ever image, astronomers have seen a star that died by exploding twice. They point at the European Southern Observatory's Very Large Telescope at supernova SNR 0509-67.5, located within the Large Magellanic Cloud, a satellite galaxy of our Milky Way in the far southern constellation of Dorado the Swordfish. This instrument lets astronomers map the distribution of chemical elements. Here, calcium is shown as blue. The two concentric shells visible prove the original star exploded twice. These patterns confirm that this star suffered a pair of explosive blasts. Only a day later, astronaut Nicole Ayers saw this. On July 3rd, Nicole was aboard the ISS when she captured this astonishing photo of pink and purple light shooting up from a thunderstorm on Earth. What she captured is called a Sprite, a phenomenon caused by intense electrical activity within thunderstorms. Sprites are triggered by lightning, but shoot up into the mesosphere instead of down to Earth. On July 16th, astronomers saw this. For the first time, international researchers pinpointed the moment when planets began to form around a star beyond the Sun. Think your very first glimpse of a baby universe. Using the ALMA telescope, in which the European Southern Observatory is a partner, and the James Webb Space Telescope, they have observed the creation of the first specks of planet-forming material, hot minerals just beginning to solidify. This finding marks the first time a planetary system has been identified at such an early stage in its formation and opens a window to the past of our own solar system. This newborn planetary system is emerging around HOPS Hops-3155, a proto or baby star that sits some 1,300 light years away from us and is an analog of the nascent Sun. On July 22nd, the first images of Comet 3I Atlas were captured by the Hubble. The Hubble Space Telescope caught its first glimpse of this comet, 3I Atlas, and it's only the third object humanity has ever observed entering the solar system from beyond its limits. Prior to 3I Atlas, the previous two interstellar invaders were 1I Oumuamua, spotted in 2017, and 2I Borisov, detected in 2019. Both have now left the solar system, though other interstellar bodies are predicted to dwell undetected in our cosmic backyard. Here is Hubble's view of interstellar 3I Atlas when it was only 277 million miles from Earth. As Space.com reported, recent research suggests that 3I Atlas could be even more exciting than initially perceived, as its trajectory through the solar system indicates it comes from a region of the Milky Way older than our 4.6 billion year old solar system. With an estimated age of 7 billion years, that would make 3I Atlas the oldest comet we've ever seen. Jumping ahead to August 19th, a new to us moon was spotted in the lineup around Uranus. This composite image of Uranus, seen in the infrared by the NASA, ESA, CSA, James Webb Space Telescope as well, showing 14 of Uranus's 29 moons, including the newly discovered one, S2025-U1. Expanding the known family of satellites to 29, the new moon is around 6 miles wide and follows a near circular orbit about 35,000 miles from Uranus' center. Most planetary bodies in the solar system are named after mythological figures, but Uranus moons break this pattern. These icy moons are named after figures in the plays of William Shakespeare and a poem by Alexander Pope. Any guesses as to what the IAU will pick for this little moon? And almost at the end of vacation time for many, this was released. The NSF Inouye Solar Telescope took this picture, record-breaking picture, of a solar flare coronal loops. They were actually taken on August 8, 2024, but not released until just this past month. It captured the sharpest ever images of a solar flare at the H-alpha wavelength, which is 656.28 nm, revealing dark coronal loop strands in unprecedented detail. The observations made during the decay phase of an X1.3 class flare measured loop widths averaging 48.2 kilometers, with some even half as narrow. By using the Inouye Solar Telescope to isolate light at the H-alpha wavelength emitted by hydrogen atoms, solar physicists can identify fine structures in the lower solar atmosphere too small to observe in the past, offering a potential breakthrough in determining the fundamental scale of coronal loops and advancing solar flare modeling. By improving researchers' ability to model solar flares, these observations will also improve forecasting for space weather events that are hazardous to satellites, power grids, and communications on Earth. So, even if you didn't manage to get out to any star parties, you can still sit back and enjoy amazing sights and information from far beyond your backyard, brought to you by the Sunday Night Astronomy Show.